Start off, we did I started by importing the necessary libraries, that is Pandas, NumPy, Matplotlib, and Seaborn. In this project, we are going to do customer segmentation analysis and look at how the different segments performed. So we uploaded our data. So we looked at the head of the data, then we dropped duplicates, and also I tried to see what null values we had in this data. There are also no null values for every column. I then went ahead and checked the data types, the column names. Then we tried to check for unique entries. So if you go ahead and pay attention to the columns named Z cost constant and Z revenue, these columns have only one unique entry each, and so I thought these are constant for every row, so there was no need to keep them. I deleted those columns using the drop function. And then we did some descriptive analysis. We had giving us the mean, standard deviation, and the 50% value, which is the median. Also looked at mode, the model value for this different. Yes, then we were creating segments. So I thought I should find out which patients are in a relationship or not. Okay, we use the if elif functions. So anyone who had married, if they had the value of 1, and anyone who had marital together as 1, we returned 1, meaning they're in relationships. And then others, we returned 0. That is basically it. And then I renamed the education column. I also ranked the different customers or I gave them different education levels or statuses. So anyone who had secondary education, I gave them 2. Then basic 1. Those who graduated with a degree, I gave them 3. And then those with a master's 4 and PhD 5. So then I created a column called education status. So off to segmentation now. So before segmenting, anyway, to do the segmentation, we use Kmeans. So we imported Kmeans from sklearn.cluster. And then we had to standardize the scales because we are using income, total amounts, whether they're in a relationship or not, and then education status. These 2 being the behavioral and this being the spending or purchasing patterns. So we're looking at income and the total amount of money spent. So we did use the standard scaler to standardize these columns. These are the columns we're going to also use for clustering. That's why we're standardizing them. And then we created a copy of our data because we don't want to mess with our original data. We created a copy and then created columns. In other words, we formed new columns, standardizing, and then forming new values for income, total amount, and then relationship status as well as education status. So that is basically what this code snippet is doing. And then I then assigned these columns a variable x, and then we are supposed to generate a list of inertia, which we are going to plot anyway against the k values, that is the number of segments. So basically, what we are doing here is we get values of k, or the number of clusters that we want. In this case, we are trying to find what is the most suitable number of clusters for this data. So to do that, we start from the very first, that is 0, up to the 11th number, that is 10. So we're looking at a number of clusters from 0 to 10. And then for every value of k, we are looping and finding and generating an inertial list, which we called inertial. We are generating inertial values, which we stored in the inertial list. So then when we generate that, the inertial values, we plot it against the number of clusters, which is starting, remember, from 0 to a range of 11, 1 to 111 is from 0 to 10. So when we plot, we come up with that. And then if you look at our plot carefully, we realize that 4 seem to be at the elbow. So I took 4 as the most suitable number of clusters. So now we know that the number of clusters that we need, or that we are going to use. We are then going to generate a column called cluster, or we are going to assign these different clients to different clusters. And there will be 4 different clusters, that is 0, 1, 2, and 3. So we use the fit command to then assign these clusters to the different clients, and then we form a new column called cluster, which will show to which cluster does each customer belong. Now I want to visualize and see these clusters, but before we do that, we shall get 2 principal components using this function, that is PCA. We shall get 2 principal components. Basically, these are like 2 characteristics, 2 general characteristics, or the most important characteristics of the different columns that enables us to see where exactly each column, each client falls, or in which cluster does each client fall. So we shall generate the 2 principal components, that is, we shall call them PC1 and PC2. Then after that, we shall plot. This is a scatter plot showing the different clusters to which the different customers belong to. So now we are trying to, after forming our clusters, we are trying to see the different properties of these clusters, what differentiates them. So when we go and check the total amount of money spent, the number of clients in each cluster, we shall get just the count of any of the columns. In this case, I use the total amount column, and then we're grouped by cluster so that we can find the number of clients in each cluster. And when we do that and we visualize, we realize that most of the clients are in cluster 0, followed by 2, 3, and then 1. When I did further analysis, I also realized that transforming the values or standardizing the scales, when I come back to analyze the characteristics of the clusters, the analysis was not as clear I was getting a lot of errors. So I decided to recluster, but based on the same columns, and then call that data df clustered, and then we created a copy so that then we can analyze the different properties of the clusters. So nothing changes here, just that we are not standardizing these columns so that we can have the original values. So basically that is what I did here. Yes. So when you go towards the end, you'll find we do not have the principal component values. We have the total amounts are basically remaining the same. We are just assigning the clusters, as you can see in the end here. So that is what I did right there. So another property would be the average income of each cluster. To get average income, we use group by. We are grouping by cluster, and then we get the mean or the average of the income column, and then we shall call that average income. When we plot that, when we get a bar plot, we realize that cluster 3 has the highest, followed by 1, then 0, and then 2. I also went ahead to see the average product consumption per cluster, how much money is being spent on each product, as well as the total products, the total amount of money spent on all products. How much on average is being spent by each cluster. So to do that, we group by the cluster, and then we shall enter a list of all the columns with averages we want to find. So those are the different products. So this is our value. So for cluster 0, 1, 2, 3, we do have the average spend per cluster for each product. So we after that we want to visualize this, but before we do that, we want to break it down for our pandas to know that each of this value is average, each of the value inside these things are consumption, and then up here is where we find the products, and then here we find the clusters. So basically that is what the meld function here is helping us with. Once we have clarified that, then we can go ahead and visualize with cluster being on the X, and then our product consumption being on the Y. And then when we visualize, we realize, so the purple is total. And then for the different products, as you can see, these are the different average consumptions of the different products by the different clusters. I also went ahead and looked at minimum level of education. It could have affected the purchasing patterns. So we found that clusters 0 and 3, the minimum was 1, and clusters 1 and 2, the minimum was level 2. That means at least everyone had secondary education, while in 0 and 3, at least everyone had basic education. I then went ahead and gave my insights and recommendations for each of the clusters. Again, I will not read through this. You can pause the video and read through. Thank you very much.